Okay. Hey guys, I'm just getting my PowerPoint here set up. I welcome you back. It's we're getting towards the end of this unit. In fact, I should probably put on here, we're preparing to take a test in here on Friday. That's going to be our first virtual remote test. Put some more details on that coming up. But just like we did area of composite shapes, those are shapes made up of different regular shapes put together. We're gonna do the same thing with volume today. Notice I've stopped having the aim on the screen. Don't worry about that. The homework tonight is in the green packet. If you don't have the green packet, I'll make sure that I post a copy of those pages for you as well as a PDF. Okay. Let's go right into the do now. Not that I'm going to have you guys do it unless you want to. If you want to, you can pause the video. Otherwise, I'm just going to kind of talk our way through it. This says find the area of the following shape. And this is that idea that, you can't find the area of a shape like this because we don't know what this shape is. But I do know that it's broken up into two different shapes, a rectangle, whose area is base times height, and a half of a circle, whose area is pi r squared. And we're going to divide that by 2 because it's half of a circle. So really, I just got to find the area of this rectangle, which would just be 13. Well, nope, it's not 13 because, 13 is the length of this whole thing. So what is the length of this thing? It's only from here to here. Well, if this whole thing is 13, I guess we got to know what this is. Oh, the diameter is 4. This would be, diameter is 8. That means that's 4. So this is 9. This is 8. 9 times 8 is 72 inches squared. Okay, the area of this circle up here is pi times 4 squared. We'll divide that by 2 because it's half of a circle. Pi times 16 divided by 2. That's going to be 8 pi. Now, I'm going to want to figure out what 8 pi is so that I can add those two things together. So I go to my calculator for this one. Let me get my calculator out. 8 times pi is equal to, let me just get this, 25 point, I'm just going to round it to the nearest hundredth for right now, 25.13. Okay, add that to 9, and that gives me the area of that whole thing is 34.13 inches squared. Okay, I'm getting rid of I forgot that I had my face up there. Let me get myself out of here. All right, so there's the area of that whole thing. Why did I have you do that, or why did I want to talk about this? Because that is going to lead us into what we're going to do today. This idea that if you want to find the area of some unique shape, sometimes you have to find the area of pieces of it. Same thing will go with volume. You're going to see some unique shapes today, but the idea would be to find the volume of some shapes that you do know. All right, with that being said, let's get right into it. All right, what is a composite three-dimensional shape? Well, we know that a composite shape is something that's made up of 2 or more standard shapes. This would be a composite three-dimensional shape. Sort of looks like a three-dimensional L shape. This is another example of a composite shape. This looks like, I don't know what you would call that. Sort of looks like a fireplace with like a chimney on it or something. And this would also be considered a composite shape. But what's different about this one than the other two is this is supposed to be like a little hole hollowed out in that shape, almost like a conical hole that's cut out of there for some reason. So the way we figure that out is going to be a little bit different than the way we do the other two, and I'm sure you can imagine. Okay, let's get into the idea of how this would work and how we'd find the volumes of these particular things. So to find the volume of a composite shape, you simply, like you would with a area composite problem, divide it into 2 shapes that you think that you could find the volume of. So I think the easiest way to do this would be to break this up into 2 rectangles, or 2 rectangular prisms, I should say. One there and one here. Now, if we can get the dimensions of those 2 rectangular prisms, and we add them together, or we find the volumes of them, then add them together, that'll be the volume of that entire shape. So we find the volume of each individual piece, which will require a little bit of thought, you'll see. Then we find the volume then we add them together, and that will determine the volume of the entire thing. Now, this is adding or subtracting. That's because on that one where we saw it sort of hollowed out the shape, we'd subtract out that volume to get the volume of the composite figure. All right, this is gone. Let's move into an actual example so we can see how this is going to work. Okay, it says try it on your own, but let's do it together. If you want to pause and do it on your own, feel free. All right, so this shape, first we got to ask ourselves, what is this shape made up of? Looks to me like it's made up of a cylinder and some sort of rectangular prism down here at the bottom. So the volume of a cylinder, pi r squared h. We're going to add that to the volume of the rectangular prism, which is just length times width times height. I'm going to pause the video now. Well, actually, you know what? Let me substitute in my numbers here. The radius for that cylinder on top is 4. The height of that cylinder is 8. The volume down here is 14 times 8 times 12. All right, let me pause while I do the math on this, and we'll come back with the answer. Okay, so now you can see that I've just got my calculator. I just did the math on both of those. I found the volume of each. Now that I have the volume of each piece, simply take them and add them together, and I end up with a total volume of 1,746.12 feet cubed. So volume, I'm going to put a little t there for volume of total. Now I rounded it to nearest hundredth just because, look for them to either tell you round to nearest hundredth, round to nearest tenth, round to nearest whole number. They'll be more specific, or I'll be more specific when it comes to a test or something like that. Okay, moving on to the next one. Okay, I got to get rid of my writing there. Okay, this one's a little bit different. This is the one where it's hollowed out. So we'll look at this, and then I'll leave you to go ahead and try your homework. Now, this one you should have, and I highlighted it before, but let me highlight it again. You should recognize that there's a prism there. So that would just be length times width times height. But there's a cone here that has to be taken out of it. So we're going to subtract this time the volume of that cone, which is going to be pi r squared h divided by 3. Okay, we learned that one yesterday. All right, let me do the substitution for the prism here. 7 times 5 times 5. Let's do the substitution for the cone. Pi times, look at the radius. The radius is not 3. It's 1.5. They tried to fool us there. The height of that cone. Maybe the height of that cone is 5 as well. Having trouble kind of reading that. I think that's supposed to be 5 as well. All right, no problem. And then from there, we're going to do the math. All right, let me hit pause. Okay, so we're back. I see what I missed, what I wasn't paying attention to before. This prism has dimensions of 7 by 5, and this is 5 this way. This 5 right here is for this thing. Forgot to tell you that this was a square bottom. That's why. That's where this comes from. Okay, anyway, there's my math for each of them. Now, just like I did before, I need to do something with the two of them, but this time I'm not going to add them together because that cone is being hollowed out of it. So I'm going to subtract it. So I'm going to take 175 and subtract from it 11.78. Again, I just rounded to the nearest hundredth because, I don't know, it just shows that it's pretty accurate that way. 163.22 centimeters cubed. Okay, and that's it for our lesson on composite volume. If you're adding unique pieces on top of each other to create a unique three-dimensional shape, you're going to be adding their volumes. If you're hollowing something out, you're going to subtract that volume out. All right, good luck. Practice on your homework. See me in Google Meet if you have any questions.